Today we're going to talk about interfaces in Java. Recently, we've been talking about abstract classes. In our last lecture, we talked about the abstract class animal. We made the animal class abstract simply because it didn't make sense to have something called an animal. An animal typically is more specific than that. A camel or a cow, for example, were the ones that we had implemented prior. So we made the animal class abstract. We also made the animal class abstract because we had this abstract method eat inside of it because each animal eats differently, eat different things, eat at different times, eat different amounts, all those kinds of things. You wouldn't feed a cat the same thing that you were feeding an elephant. So um, we had this abstract method, and the deal between an abstract class and one of its concrete subclasses is that that subclass will implement the any abstract methods. So you'll see that our camel class has an eat method, that our cow class has an eat method, and I've created a new cat class, very simple, that also has an eat method. um, so what we want to talk about today are, what else is a cat? Well, a cat also could be a pet if it's a house cat. So what if we were to make another abstract class called pet that allowed a cat to have a play method or forced a cat to have a play method? See, the problem we run into in Java and many languages is that Java does not allow um, multiple inheritance. In other words, one class cannot come from or extend multiple classes. The reason for that is that because when we call super, how would it know which way to go? Or if we called to string and didn't write it to string function, which chain would it have to go up? So for that reason, JavaScript only allows single inheritance. But there is another option. Our next option is to make something called an interface. So now for the first time, instead of doing new class, I'm going to do new interface. And I'm going to call it pet. So you'll see that the new file says public interface pet instead of public class pet. Now, an interface is kind of like uh, an abstract class on steroids. So where an abstract class operated in a lot of ways like our normal classes because it allowed you to have that instance variables and class variables and instance methods and class methods um, and abstract methods. An interface does not allow that. In an interface, all methods are abstract and all variables must be static. So there are no instance variables and all methods will be abstract, which means we don't have to declare them as abstract even because they have no choice. They have to be abstract. So my pet method is going to be very simple. It's going to have a method called play in it, public void play, because our pets typically do something that we would assimilate or call playing. And that's it. That's going to be my whole interface. And now when I go back to cat, while I can't extend animal and pet, I can extend animal and I can do what's called implements pet. You extend a class, you implement an interface. Now, all that we've done here is created a new contract. Just like by extending animal, we agreed to say that cat will implement any abstract methods like eat. When we implement pet, we're saying the same thing. We're saying that cat now must have any of the methods that are inside of pet, and it's got to have a body. So we say public void play system out print line. Cat chased its tail. Well, again, you'll probably ask, why would we need to do that? Why can't we just write a play method? Why do we have to create an interface, implement that interface to have this play method? Well, we don't. We could just have a play method, but that play method would be specific to cat. So let's make now another class, another subclass of animal, and this will be dog. And so it needs a constructor takes name and sound and just calls super, sending those things in. And it needs now an eat method. Oh, sorry, that's got to extends animal. And it also needs an eat method because it's extending animal. Okay. Now, if I take the dog class and I add implements pet, dog class then has to have play, public void play, system.out.println, the dog takes the ball. All right, so now I have these two classes, cat and dog, which are extending animal and implementing pet. So I can come back here and I have a cat that I've created, and now I'm going to make a dog. I'll call him Rover. Right, and we'll add him to our list as well. And when I run this, you'll see, as we saw before, that I'm calling for each animal in the list a.eat. And because animal has the eat method, then the compiler allows that to happen. But each object calls its own eat method. Well, I can make another array list here, this time of type pet. So let's call this list two, sorry. And so now what we're going to do is we're going to say list2.add peaches and list2.add rover, right? And so just like an abstract class, I'm allowed to do something like this, pet p equals new cat, name meow, right? So I can create a cat, I can instantiate a cat and store it in a pet, which means I can take those things and I can push them in here. Now, if I try to do this, pet p in list two, if I try to do p.eat, I'm going to get an error because while the cat and dog classes have an eat method, the pet class does not have an eat method. Okay. Um, but I can do p.play. So what having an interface does for me is it does a number of things. First, it gives me another way to classify some of my objects, some of my classes. And secondly, it is another way that I can provide a contract forcing a method to have a certain, forcing a class to have a certain method. All right. One of the more popular um, interfaces that we use is the comparable interface, and the comparable interface has the compare to method in it. So, for example, and this doesn't even make any sense. First off, we should say that while we can only do single inheritance, we can implement as many interfaces as we want. So I can implement comparable here. And when I do that, it just says, hey, you need to have this method. So there it is. So there's my compare to method, which would allow me to compare two dogs. I can string as many of these things as I want out here, and that's okay because I'm not calling super to get to any of them. And if by some chance two of these interfaces had the same exact method in them, that's okay as long as I implement that method. Because remember, the methods in these interfaces are empty. They don't have any code that I'm overwriting. They're just creating a contract that I have to fulfill in order to be able to make that a concrete class. So again, interfaces is kind of the next step in abstraction. You know, we've got classes, superclasses, and subclasses, and then we make some of those superclasses abstract classes. So they've got some abstract pieces and some concrete pieces. But then once we get up to an interface, it is all abstract all the time. And once again, an interface is not allowed to have an instance variable. If I try to do private int age, I'm going to get an error, and it's going to say that I cannot have instance variables. I could make a static integer. I could make essentially a class variable and give it a value, but I'm not going to do that because I don't need that, and it doesn't really make any sense in this case. They also have to be final, not unchanging, so they be constants as well. Um, so anyway, that's interfaces in a nutshell. Good luck on the lab, and I'll see you in the next video where we talk about the results of the interfaces lab. Thanks.